Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 11. The question is, a thin rod of mass m, small m, carrying uniform negative charge small minus q, is placed symmetrically along the axis of a thin ring of radius capital R, carrying uniformly distributed charge capital Q. This is the ring. This is the rod. The ring is held fixed in free space and length of the rod is 2r. Find period of the small amplitude oscillation of the rod along the axis of the ring. Let us solve this question. Collected all data over here. Mass of the thin rod is m, small m. Charge on the thin rod is minus q, uniformly distributed over it. The rod is placed symmetrically along the axis of the thin ring of radius r. What does it mean? Symmetrically means half of the rod is above the ring plane and half of the length of the rod is below the ring plane. We have taken y axis in this direction. The ring is held fixed in the free space. Ring has been held fixed in the free space. The length of the rod is 2r. These all things are given in the question. So collected all the data for convenience. To find is the period of oscillation when the rod is displaced along the axis of the ring by a small amplitude. So initially the rod is symmetrically placed on the axis of the ring. It means half of the rod is above, half of the rod is down. When it is symmetrically placed, so half of the rod which is above the center O of the ring will have minus q by 2 total charge on it, and below will be having minus q by 2 total charge on it. So above part will be pulled down by the electrostatic force and lower part will be pulled up. But the charge on the above and the below is same, so the force will cancel out each other and the rod will be in equilibrium in such condition. Now in this diagram, if you see, this rod has been shifted by delta y, small amplitude. For easy viewing, it has been magnified. You can consider this as a small amplitude. So the rod has been displaced in y direction by delta y. So it means the portion of the rod which is above the ring plane is increased by a length of delta y and below part reduced by a length of delta y. From the formula we know that on the axis of the ring at a distance r, the E field will be K into Q into R divided by this, and you will reach to this expression. So because of such shift, what net force will work now on the rod we can write like this: F prime on the upper part of the rod. U stands for upper, R is rod. L stands for lower, R is rod. Will be lambda into delta Y. Lambda we have taken as charge, linear charge density on the rod. So only this much change has come. So this much. So because of such change, the force will increase in this direction by this amount. Lambda into delta Y into E. And for the lower part of the rod, we can write lambda this much minus delta Y, means delta Y, this much length has reduced. So we are writing is minus delta Y, because now initially it was R, now it is R minus delta Y length below the plane of the ring. So how much charge reduced from below will be this much, lambda into minus delta Y into E. So this will be the force on the lower part of the rod. But this being negative, it will be working in the this direction towards the O, up. This sign is for upward direction, this one is lower direction. So we will put the value of E. When we change the sign plus to minus, what we will have to do? We will have to change the sign of the direction. We will have to reverse the direction of the arrow. So it has been written like this. So the net force will be this much, K, 2 times K into capital U Q, 2 times K capital Q, linear density lambda delta Y divided by 2 square root of 2 R square in denominator. This net force will be equal to, from Newton's law of motion, we can write as mass into acceleration. So acceleration will be this much. And we know from simple harmonic motion that this will be equal to the omega square, that is angular frequency, square of the angular frequency into delta Y. So omega square is your this part, 2kq lambda divided by m into 2 root 2 r square. So omega will be this. Omega can further be written as 2 pi by time period of oscillation. And finally, upon solving, you will be getting T is equal to 4 pi R in bracket 2 root 2 pi epsilon naught M into capital R divided by capital Q into Q, the whole bracket closed, the whole thing is under root. So this will be the time period of oscillation. Hope you understood the concept of solving it. In case of any doubt, please do write in the comment box. I will clarify that point. Thank you.